Okay, this video is to cover Unit 1, Day 3. We're going to go over atomic structure. Here is your important dates coming up. We have a quiz today in class, or on 8/22. This quiz is going to be on Canvas. You can go take it there. Here's our objective for today. Pause the video if you need to. Our homework for tonight is page 27 and 28. Is that correct? I think it's actually... Yeah, 27 and 28. Yeah, second guessing myself. Okay, so that's your homework for tonight. We're going to go do today's notes. All right, so turn to page 17 in your booklet. Pause if you need to. So we're going to go over atomic structure. This is how your atoms are set up. This is stuff you should probably already know, but if you don't, that's okay. All right, so atoms are going to be the smallest particle of an element that has all those properties of the element. Okay, atoms are extremely small. So a copper atom has a diameter of 0.000000128 millimeters. That's itty bitty teeny tiny. Okay, so if I look at like a handful of iron nails, they're really small, right? And each atom inside of those iron nails are very small, like what you see here. And then you look at each one of those atoms, look like this, and it breaks down even smaller. So these are tiny, tiny things. We have 3 subatomic particles, sub meaning it's smaller than your atom, okay? That includes your P stands for protons, and protons are positive. Remember, we got that big old plus sign in our name right there. E stands for electrons, and those are negative. And then we have N, which is our neutrons, and those are neutral. Remember, neutron and neutral both start with NEU. It's an easy way to remember that. Boop, boop. Okay? Sorry, I'm fixing my thing. Okay, so our nucleus is the tiny positive core of an atom, which contains most of the mass of the atom. Remember, our nucleus holds our protons and our neutrons, and if we look down here, we can see that. Our protons and our neutrons both make up the mass of the atom, because electrons are like earrings. They don't have a weight, okay? The protons, making sure my microphone is on. The proton is the positively charged particle found in the nucleus of the atom. So it's inside the nucleus. It has a charge of +1. Each one has a charge of +1. Okay? The neutron, which is an N with a little 0. The formatting here is a little wrong, so it should be a little N with a little 0 up top, is a particle with no charge, so 0, found in the nucleus of the atom. And then the electron is the negatively charged, so it has a charge of -1 particle found outside of the nucleus. So if we're looking at our atom down here, we have a big old nucleus, and our nucleus looks like this. We have our positive protons and our neutral neutrons in there. Okay, if I have a nucleus that has a positive and a neutral in there, that means my nucleus is overall positive. Okay, it becomes neutral once you add those electrons in there, because if I have an equal number of positives and negatives, it equals out. So if I have 6 protons and 6 electrons, that's 6 positives and 6 negatives, that equals 0, right? That means I'm neutral. That means I'm just like meh, right? But if I have more protons or more electrons, that changes my overall charge of my atom. Usually it's the electrons that move around. Okay, so my subatomic particle, to summarize, has a positive charge, and it has a mass of 1 AMU. That stands for atomic mass units. Okay, my neutrons are neutral with that neutral charge of 0, and they weigh 1 AMU. That's atomic mass unit. Okay, then my electrons are negative. They have a -1 charge, and they weigh 0.0005 AMU. So for all purposes for this class, it's going to be practically 0. We're going to ignore the weight of electrons. All right? So if I'm looking at my periodic table, and that looks like this. We've all seen a periodic table. Okay. We see these cute little symbols. They look like this. Okay, my atomic number is the number of protons in an atom, and it identifies the element. So think of your atomic number as like your social security number. Everybody has a unique social security number. In a neutral atom, the number of protons is equal to the number of electrons. So, atomic number, oops, what am I doing? Atomic number is equal to the number of protons, it's equal to the number of electrons. That cute little acronym right there is not erase. What am I doing? Highlight. APE. So, APE stands for atomic number equals protons equals electrons. That's an acronym you want to remember to save your butt. Okay, your mass number is the average atomic mass rounded to the nearest whole number. So if I have a mass number down here of 4.003, to round it to the nearest whole number, that would be 4. So my atomic mass is 4.003. My mass number is 4. All right, so for example, helium has 2 protons. And I know that protons equal electrons, so I have the same number of electrons. The average atomic mass of helium is 4.003. So my mass number, once I round it, is that 4. How easy. So simple. Okay, so let's practice a whole bunch of these. All right, I have potassium. My atomic number is 19. So the number of protons is equal to my atomic number, which is 19, which is equal to the number of my electrons, 19. All right. So then I take my mass number. I'm going to round my atomic mass from 39.0 to 39. Subtract my atomic number, which is 19. That gives me 20 neutrons. All right. So let's look at these. I want you to pause the video and work through these on your own, and then check your answers with me. All right. So we're going to look at helium first. Pause, work it out. Welcome back. I have 2 protons, 2 electrons, and then I take my mass number, 4, minus my protons, 2. So I have a total number of 2 neutrons. Okay, let's look at carbon over here. Carbon has 6 protons, so I have 6 electrons. And my neutrons are 12 minus 6, so I have 6 neutrons. All right, on to silver. Silver, I have 47 protons, which means I have 47 electrons. Then I take my mass number, I'm going to round 107.8 to 108, subtract 47, which gives me 61 neutrons. All right, I want you to do these 3 on your own. If you go look at the PowerPoint later, you can find the correct answers. All right. This looks very similar to what we did on our stations. It's also what you have on your homework, and you're going to have a bunch of questions like this on your test, where you're just given one part of it and you have to go find the information about it. So I have an atomic number of 13. It's telling me that it's Al, and then my average atomic mass is 26.982. Before I go look at a periodic table, I know that my atomic number is equal to the number of protons, which is equal to the number of electrons. So I can automatically fill this in on the entire table. So I know that this one with 13 is 13 protons, 13 electrons. This one with 11 is 11 protons, 11 electrons. And this one with 8 is 8 protons, 8 electrons. Okay? Now let's go fill out the rest of number 1. Okay, number 1, I don't know if you have this memorized. Probably not, but it's okay. Al is aluminum. You can see, I can't mark on this page. But it's number 13. Oh, yeah, I can zoom in. Right there. So aluminum is my element. And I'm going to take my mass number, which is over here. 27 minus 13 gives me 14 neutrons. All right? Let's look at number 2. Number 2 tells me it's sodium. I'm given the number of neutrons, so I don't have to go solve for that, but I need to go find my atomic symbol and my average atomic mass. So let's look for sodium. It says that its atomic number is 11, so I'm going to peek back this way. Number 11, sodium. And my mass is 22.990. So 22.990. And if we look back at it, sodium has a different symbol from its name. So sodium, it starts with an S. Its symbol starts with an Na. Or it is Na. So capital N, little a. All right. And boom, we have that filled in. The next one, I need to just go find my name and symbol. I have 8 as my atomic number. So we're going to go peep back across over here. I have 8 right there. Okay, 8 is oxygen. Its symbol is O. Big O. Oh my gosh, that is the worst O I've ever seen. Okay, fix it. Oh, ta-da! I hope y'all feel pretty confident about this since you did it last class. It's okay if you don't, because we're going to work on it. All right, so the second half of this acronym that I taught y'all, so APE is the first half, MAN is the second half. So I want you to highlight this in your notes. APE, A-P-E, there's the A, there's the P, there's the E. And then MAN is down here. Mass number minus atomic number equals neutrons. That is super important. What star is that? Oh my gosh. That's super important. There we go. Sorry if that was a little chaotic. It's okay. All right, on to isotopes. Isotopes are super fun. All right, so isotope means form. Okay, so remember Dalton has 2 of his rules that we don't follow anymore, or we don't follow to a T. They're not entirely true. He said that all atoms are identical, but now we know that there are tiny differences. So if I look over here at this little table, I have carbon 12, carbon 13, and carbon 14. There's something different about all 3 of those. The number of protons stays the same because remember, your protons are like your identity. It's like your social security number. But the number of neutrons changed each time. And because I changed the neutron, I changed my mass because remember, your protons and your neutrons make your mass. Okay, so isotopes have the same number of protons, but their masses are different from having different numbers of neutrons. I'll tell you right now, that question is on your test. Okay? Isotopes of carbon have the same chemical properties. Whoops, that's my highlighter. I can't write, apparently. Properties. because they have the same number of protons. Remember, their identity is the same, so they act the same chemically. So the mass number, remember that's the rounded version of an isotope, will be the number after the element's name. This is called isotopic notation. And there's two ways. So way number one is what I'm saying right here, where it has the element's name. So carbon, comma, dash, mass. So 16. So name, dash, mass number. That's the rounded version. Okay, the mass number is the sum of the protons and neutrons in the nucleus. But we already knew this because we're super smart, right? All right, so we're looking at different versions of potassium. I have potassium 39, 40, and 41. Since it's all potassium, the number of protons stays the same. That's why it's already filled in. Okay, the number of electrons stays the same because I'm not changing the charge on my elements. I'm just changing the mass. So remember, we have man. That's my second part of the acronym. Mass minus atomic number equals neutrons. So I have my mass up here minus my protons, because remember, your protons are your atomic number. Okay, equals my neutrons. So I have 39 minus 19 equals 20 neutrons for potassium 39. All right, you do potassium 40 and 41. Go find how many neutrons it has. I bet you can do it. Y'all are so smart. Or I guess I can do it because there's a whole table down here. So if I look at potassium 40, I have 40 minus 19. That should give me 21 neutrons. Then for 41 minus 19, I should have 22 neutrons. Super easy. Okay, so let's look at phosphorus 32. Let's go find phosphorus first. Where is it at? Oh, there it is. Okay, phosphorus is 30.974. Its atomic number is 15. That's the main thing. I'm looking for that 15. So I have 15 protons, 15 electrons, and I didn't need to look at the mass because the mass is right here. So I have 32 minus 15, and I can't do mental math. Y'all will make fun of me. 32 minus 15 is 17 neutrons. Okay, sulfur 34. So I'm going to have 34 over here minus something, right? Let's go find sulfur. It's right there. Sulfur has 16 as its atomic number. So I have 16 protons, 16 electrons, and then 34 minus 16 gives me 18 neutrons. All right, fluorine. Fluorine's a fun one. She's right here. Fluorine has an atomic number of 9. So 9 protons, 9 electrons. And then to find my neutrons, I use this mass number, 18 minus 9. That gives me 9 neutrons. All right, and then I want you to do bromine 81. You can go find the answer in the PowerPoint on Canvas. Okay, so we learned one type of isotopic symbol or isotopic notation. So that was like if I did carbon 16. You have your element name, dash, and then you have your mass number. And remember, that's your protons plus your neutrons. Okay, the second type of isotopic notation is this fun little one we have up here. You have your symbol, okay? So not the name, like what we have here. We're using our symbol, okay? Symbol, and then we have a superscript that goes before the symbol. That's my mass number. Remember, your mass number is your protons plus your neutrons. On the bottom, so my subscript, is my atomic number. And my atomic number is equal to the number of protons. I'm telling you this because we're going to use it. Okay, so for example, I'm looking over here at helium. Okay, I have a mass number of 4, an atomic number of 2. So if I want to go find the number of neutrons, you set it up like a little flashcard, right? You've got 4 minus 2. That tells me I have, what the heck? 4 minus 2. So I have 2 neutrons. Okay, let's look at these two down here. I have copper and kryptonite. Kryptonite? Krypton. Pfft. Okay, copper has 29 protons because that bottom number is my atomic number and number of protons. Okay, remember protons are equal to the number of electrons. So I have 29 electrons. And then for neutrons, 63 minus 29 is 34. Boom, boom, same number. Okay, I want you to do krypton. And if you need the answer, it's going to be on, again, the PowerPoint on Canvas. Okay, thank you for watching my notes today. I hope you have a great day. I will see you whenever I return. Okay, bye.